I started writing a third as a decimal in 1984. I'm still going. Today is recurring decimals. We can convert a fraction into a decimal using the bus stop method. So to convert 10 over 33, we're going to start asking ourselves how many 33s are there in 1? Well, there's none, so let's move that across. How many 33s in 10? Still 0, so let's carry that across. How many 33s in 100? There's going to be 3, but we're going to carry 1. How many 33s in 10? Again, still 0. How many 33s in 100? There's going to be 3, remainder 1. And you can see that we've got ourselves a repeating pattern here. This will go on forever. So the 1 and the 10 seem to be making a repeating pattern. If this happens, we have a recurring decimal. We can show a recurring decimal by putting a dot over the digit that starts the pattern and a dot over the digit that ends it. The 3 starts it and the 0 ends it, therefore they each have a dot. Note that you will only ever have a maximum of 2 dots for a recurring number. Let's have a go at these questions. To convert a recurring decimal into a fraction, we can use algebra. Start by writing out a small part of the repeating pattern. We can call this x. We need to get one sequence of the repeating pattern in front of the decimal point. Since there is only one repeating digit, the 5, we can multiply this by 10. 10 times x is 10x, and the 0.5555 times 10 is 5.555. Next, we subtract the 2 going downwards. Notice that this will subtract the entire repeating pattern. We can then divide both sides of the equation by the number before the x. This will give us our fraction of 5 divided by 9, or 5 over 9. This time there are 2 digits repeating, so we first of all write out a little bit of the sequence and we label this as x, but we're going to have to times this by 100 now to get the 1 and the 3 in front of the decimal point. Next we subtract, so 100x take away x is 99x, and the 13.1313 take away the 0.1313 will just get rid of the repeating sequence, so we'll leave 13. Finally, we divide both sides by 99, so x equals 13 divided by 99, or 13 over 99. To convert this to a fraction, we're going to start off by writing out a small part of the repeating sequence. This time it's 0.027727. We're going to label this as x. Now you will have noticed if there's one repeating digit, we times by 10 in this next stage. If there's 2 repeating digits, we times by 100. We've got 2 repeating digits here, so we're going to times by 100. Notice that we've got the 2.7, then the recurring decimal, and on the bottom we've got 0.0 and then the recurring decimal. So when we subtract, we're going to end up with 99x equals the 2.7. We're going to continue as we would normally by dividing 99 both sides, and so we have x equals 2.7 over 99. Now this is a problem, you can't have a decimal in a fraction, so we're going to get rid of the decimal by timesing top and bottom by 10. 27 and 990 are both in the 9 times table, so we can also divide them by 9. Let's finish with this. Explain how you can convert 0.34 recurring to a fraction in your head. If you know the answer, write it in the comments below. And you can also come to onmaths.com or click the link in the description where you can access all of our free GCSE papers and predictions, and you can even save your scores with a free account. This video is part of a larger GCSE course that you can follow along with at onmaths.com.